Snakes are the youngest group among all reptiles. They appeared roughly 150 million years ago, toward the end of the Jurassic period. Their emergence is tied to many fascinating facts and scientific mysteries. The thing is, snakes didn't develop their unique body structure through a slow evolutionary process driven by changing environmental conditions. Instead, the loss of limbs was most likely caused by a genetic mutation that became fixed, paving the way for the incredible diversity of species we see today. Interestingly, this version of snake's origin aligns surprisingly well with the account described in religious texts. Today, our planet is home to an enormous variety of snake species. Over the course of their evolutionary journey, some not only fed on small dinosaurs but also survived the Cretaceous Paleogene extinction event that wiped out the giant reptiles. Among them were true giants, some reaching lengths of up to 15 meters and weighing as much as a ton. Yet, science still hasn't fully unraveled how lizards transformed into snakes. Researchers have never seriously doubted that snakes descended from lizards, but the reasons behind their abandonment of legs in favor of such an unusual mode of movement remain hotly debated. As far back as the early 19th century, the French naturalist Jean-Baptiste Lamarck proposed that legs became a hindrance for a group of lizards living in rocky terrain. They made it harder to squeeze through narrow gaps and slowed them down during hunts. A long, elongated body also made it easier to hide from predators. However, nearly all modern four-legged lizards are far faster than snakes. Limbs don't hinder their ability to thrive in diverse habitats or traverse any surface. Most lizards hunt insects, which demands agility, while legless snakes, over time, were forced to shift their diet to smaller prey, even evolving venom to aid in hunting. Another theory about snakes' origin suggests their ancestors transitioned to an aquatic or semi-aquatic lifestyle. Proponents of this idea argue that as lizards began swimming, their bodies adapted for greater hydrodynamic efficiency. A perfect example to illustrate this theory is an extinct snake known as Pachyraches or Pachyraches. This genus of snakes lived in freshwater habitats across Palestine and other parts of the Middle East during the early Cretaceous period and shared many traits with lizards. Some even call Pachyraches a lizard with snake-like features, though most scientists agree it was likely a transitional form between lizards and snakes. Its head resembled that of modern pythons, its body was covered in snake-like scales, and near its anal opening, it had two tiny vestigial legs. Pachyraches primarily fed on fish, grew up to 1 meter in length, and weighed around 1 kilogram. It swam like a snake, undulating its body horizontally. However, this theory has significant contradictions. For one, no known group of primitive aquatic snakes ever developed specialized adaptations for underwater movement beyond an elongated, limbless body, features found only in more advanced modern species, like sea snakes. Additionally, there's no evidence of prehistoric snakes that lived exclusively in water. Their fossils are more commonly found in terrestrial deposits, even though such remains preserve far worse there than in marine or river sediments. On the other hand, there are plenty of lizard species that lost their limbs after adapting to a burrowing lifestyle, such as skinks, slowworms, and flap-footed lizards. It's possible that this shift in behavior drove the earliest snakes to modify their body structure. Supporting this theory is the disappearance of external ear openings and movable eyelids, features unnecessary in damp soil, where eyes don't require constant moisture and sealed ears keep dirt out. There's a strong case to be made that this is how the ancestors of all modern snakes emerged. For a long time, scientists believed snakes descended from monitor lizards. The two share many similarities, most notably a forked tongue used as a scent organ. Both analyze particles in the air or those collected by flicking their tongues using a specialized mechanism, the Jacobson's organ, a sort of chemical analyzer consisting of two openings in the upper palate. Snakes and monitors also share key vertebral structures, and some Pacific Island monitor species even lack external ear openings, just like snakes. However, recent genetic studies reveal that these species are actually quite distantly related. Moreover, there are no known burrowing monitor lizards on Earth today. Surprisingly, snakes share a closer kinship with geckos. Their skull structures are remarkably similar, and some gecko species even have a transparent membrane covering their eyes instead of movable eyelids. Take the flap-footed lizards, for example. Though technically lizards, they look almost snake-like with their elongated bodies and tiny vestigial hind legs. They lack front limbs entirely. Scientists believe the common ancestor of snakes and geckos branched off from other reptiles around 180 million years ago, with snakes emerging as a distinct group roughly 150 million years ago. But the biggest mystery in snake evolution remains the sudden loss of limbs. When researchers examined fossils of Eupotophus, a Cretaceous-era snake that lived about 100 million years ago, they proposed that limbless reptiles might have resulted from a genetic anomaly. A team of French scientists used X-ray imaging to study these fossils and discovered something fascinating. This transitional creature had well-developed hind limbs. The thigh and shin bones of Eupotophus, an aquatic snake that once swam in the Tethys Ocean near the Middle East, were structurally identical to those of modern lizards, just smaller. It even had ankles, though no feet or toes. Further studies revealed that snakes, unlike other reptiles, lack or have heavily modified certain genes responsible for developing the lower body, specifically those governing hind limb formation. This suggests that, for some reason, these bones stopped developing in snake ancestors at the embryonic stage. Such a drastic change could only result from genetic mutations, possibly triggered by radiation, environmental stress, dietary shifts, or even infections, though spontaneous genetic errors can't be ruled out. The key takeaway? One mutant lizard from the Jurassic not only survived without legs but thrived, passing this mutation to its descendants and spawning an entirely new branch of reptiles. And here, recent scientific research, oddly enough, has fully confirmed the theory of the origin of snakes, recorded in the 8th century before Christ in a book sacred to some religions, namely the Torah. According to Scripture, as punishment for the serpent's deceit in the Garden of Eden, its offspring were cursed to crawl on its belly and eat dust. Notably, the text doesn't describe limbs being torn off, but implies a genetic alteration. Science-backed evidence that early snakes adapted to a burrowing lifestyle, eating dust, aligns eerily well with this ancient account. Whether a bizarre coincidence or proof that our ancestors understood natural laws better than we think, the parallels are undeniable. Thanks for sticking with us till the end. If you're curious about these giant reptiles or the evolution of Earth's past inhabitants, check out our other videos.